Okay, this is Gas Laws Review Worksheet number 5. So, as I read this problem, a sample of gas has a volume of 852 milliliters at 25 degrees Celsius. What Celsius temperature is necessary for the gas to have a volume of 945 milliliters? So, the big clue here, as far as whether you use PV equals nRT or you use the P1 V1 equals over N1 T1 equals P2 V2 over N2 T2 is do you have a variable that's changing? So you can see your volume is changing here. And since you have a variable that's changing, you use this equation. All right, so then what I want to do is cancel out anything that's not mentioned or is said to be constant. So in this, it looks like they don't mention pressure. So I get rid of pressure, and they don't mention anything about the amount of gas or moles. So I get rid of moles, which means the equation I'm using is simply V1 over T1 equals V2 over T2. Okay, so now all I have to do is plug in. Now remember, the only thing that you have to remember here is your units have to match, with the exception of temperature, which always has to be in Kelvin. So Kelvin, you always have to do that change. So we can go ahead and do that really quickly. As you see right up here, you just add 273. So your temperature then is 25 plus 273, which would be 298 Kelvin. Okay, so I'm gonna plug in my numbers now. So first we have our volumes. So our first volume is 852, and our second volume is 945. So those are coming right from here. And then I'm going to plug in my temperature, which is right here. So that goes in for T1 to 98. And then I am solving for T2. So all I'm going to do here is cross multiply and divide. And that gives me an answer of, for T2, 331 Kelvin. And if you notice in the problem, however, there's one last step we have to take care of, is it wants to know what Celsius temperature. So we have to calculate in Kelvin, and then we have to change it back. So if going from Celsius to Kelvin is adding 273, hopefully it makes sense that going from Kelvin to Celsius is just subtracting. So I'm just going to subtract 273 from this number. And our answer in Celsius is going to be 58 degrees C. So that would be your final answer. Okay, that's it.